All right, now, we've been talking about conditional statements, and what I want to do in this video is talk about the first thing that you can do with conditional statements. Granted, you need a little bit more than that. And this is going to be our first logical rule. Now, there's a couple of different kinds of logical rules. There are rules of inference. That's basically where, given some stuff, we figure some other things out. There are rules of substitution, where basically you take something that's there and switch it out for something else, and you can do that back and forth or vice versa. And then there are also what I'll call situational theorems, which are, in certain circumstances, there's some moves that we can use, but they require the circumstances to do it. So and there's only going to be two of those, so I'm not really worried about that yet. We're not there yet. Well, let's start with our first rule of inference. This rule of inference is called Modus Ponens. Modus Ponens. What does that mean? Literally, mode that affirms by affirming. Not that catchy. Way that we're going to represent it in here to let you know that Modus Ponens is going on. I have a cute little nickname for it. I call it arrow out. Some people prefer the MP, good for them. I'm going to call it arrow out. Here's what it looks like. So Modus Ponens, or arrow out, works this way. If you've got certain stuff, then you can do things with it. That's pretty much every logical rule, is that if you've got some things to work with, you can get these things. And what the rules are, they're the guides to what we can get. What does that look like? Well, Modus Ponens looks like this. You've got some kind of conditional statement. I'm just throwing A and B out there. It could be anything. You get some kind of conditional statement. And this is something that's been given to you as an assumption. So you've got a conditional statement. Also, separately, you've got the antecedent by itself. It's been given to you as an assumption. So over here, I've got the right column. These are the labels for what these things are. Okay, so I've got this. This has been, if you ever studied geometry, often I remember them calling these givens. So this has been given to you. Okay, you got an arrow statement. This has been given to you. You've got this simple proposition. Now, the simple proposition happens to be the affirmation of the antecedent. What does that allow you to do? Well, let's fill in some variables in here and see if this works. Just here, I'm going to have A stand for, and I can make it stand for anything. I work, and B stand for I get paid. I think most of us accept the veracity that is the truth of this conditional statement. If I work, then I get paid. I don't think most people would disagree with that. And sometimes we can do things like helping out, like I'll do it without pay, I'll do it pro bono. Most of the time, I'm going to tell you don't work for free. But at any rate, here we go. So let's say A stands for I work, and B stands for I get paid. What does it say? If I work, then I get paid. That's it. I've got that. So if I work, then I get paid. 2. And we'll put it in the past tense just to make it a little bit easier to digest. I worked. Okay, so I've got these two statements. If I work, then I get paid. I worked. So what do I know? What can I conclude necessarily, assuming that these things are true? What's the valid deduction I can get? So if I work, then I get paid. I worked. What's going to happen? I get paid. If the statement, if I work, then I get paid, is true. Now, maybe it's a lie. Maybe someone said, sure, I'll pay you to do this. This is why people end up in court, okay? And end up suing, like the People's Court or something like that. I was supposed to get paid, and I did not get my $500. Well, what's going on in those particular instances? People are saying, I was promised this condition, I was not received this condition, and this should follow. But what this deductive argument is telling us is that if these things are true, then this should follow necessarily, assuming that they're true. Maybe they're not. Okay? This happens, again, in real life all the time. That's why people sue one another, is because there are lies here. But we are able to say something is a lie if we can point to something like this and say, here's what should have happened here. So we got this condition was sufficiently met. That's why another word for the antecedent is sufficient condition. This was sufficiently met, so this should necessarily follow. That's logic. This is the most simple deduction. Maybe I shouldn't use the word simple there. This is the most elementary deduction that you could really make with conditionals. Now, what do I do here? This was an assumption, this was an assumption. This is not something I started with, this is something that I got. Kind of like in mathematics, you know, if I say something like 2 times 2, that's what's giving to me, and then I go, oh, that's 4. Okay, this is the product. What do I say this is over here? It was not something I was giving, it's a product that I got. What product of what? Well, product of using this process. Arrow out. So here's what I'm going to do. So here's arrow out. So what you do here is you tag what you did to get this. So if it's not something that you were given, what you need to do is tag, what did I do to get this? And what pieces did I use to get this? So modus ponens is the rule where if you have an arrow statement and you have an affirmation that is the left side of the arrow by itself somewhere else, you can take those 2 things together and you can churn out the right side of the arrow by itself. I'll say that one more time for simplicity. You got an arrow, look at its left and right sides. If you've got the left side of that arrow somewhere, independently, by itself, no parentheses around it, just whatever it is, what you can do, this plus this means you can get the right side of that arrow out by itself, hence the name, arrow out. Now what things did we use in order to get this B? What lines did we use? Well, I said, we need the arrow and the left side of the arrow. Where were those found? Line 1, line 2. So, this is by the way, this is a logical proof for modus ponens. Given this, and given this, you can get this by means of this. Now, this is arrow out, this is a deduction. This is actually a logical proof. It's a very simple proof, but this is a proof showing that if you got this and this, you can get this. Well, how? I just proved it. Literally. So, basically the rest of this class is going to be a lot of stuff like this, getting a little bit more and more sophisticated as we go through the semester. Well, this semester is short for us, but nevertheless, it's going to get a little bit more and more complicated, and I'll keep doing more and more of these videos to hopefully help you understand these things in a rudimentary fashion. So in the next video, what I want to do is practice doing this modus ponens with problems that we have to translate. So where we're given things in English, we need to get those things down. So we'll work on translations and translating proofs as well, and then solving for whatever condition.